Good day, everyone. My name is Graphics. In this video, we want to study an aspect of dynamics, which is velocity time graph. We'll be using graphical method to analyze the motion of an object. And in this video, we want to solve a particular problem. And the question goes like this. It says, on a long straight road, a car accelerates uniformly from rest, reaching a speed of 54 km/h in 10 seconds. It maintained this speed for 3 km behind a truck until a suitable opportunity for passing the truck exists. The car then accelerates uniformly to 90 km/h in further 10 seconds. After maintaining this speed for 5 minutes, the car is brought to rest by a uniform deceleration of 2.5 meter per second square. Illustrate the motion in a suitable diagram and compute Roman figure 1, the total speed traveled, Roman figure 2, the total time taken, Roman figure 3, the average speed. Now, solution. This question here is a velocity time graph, right? We're using the graphical way to analyze this question. First of all, you draw your axis, your velocity against your time. So the velocity will be on the vertical axis and the time will be on the horizontal axis. We'll write it V in bracket meter per seconds here, and T time, the unit is what? Also seconds here. Now we'll start. It says, on a long straight road, a car accelerates. Now, this is the initial point here, the origin. We'll call it the origin. At that point, at the origin, our u, which is the initial velocity, is 0, right? But now we are told the body accelerates. We are dealing with acceleration here. I will know acceleration is the rate at which velocity changes with time, right? So as velocity changes with respect to time, we'll call it acceleration. I'll use this inclined line to represent acceleration on a velocity time graph, right? So when I place it this way, I'll draw this up. I'll call that point V1. I will say it accelerates at what? It accelerates from rest, reaching a speed of 54 km/h in 10 seconds. So it means my V1 is 54 km/h. Then in 10 seconds, this is how I am going to represent it, right? Now, what you need to understand is our velocity is in meter per seconds, but what we're giving here is in kilometer per hour. Now, you're going to convert kilometer per hour into meter per seconds. How will you do that? You multiply 54 times 1000 divided by 3600. And if you do the needful, this will give us 15 meter per second. So the velocity V1 is equals to what? 15 meter per seconds. Now we'll continue. It maintained the speed for 3 kilometers behind the truck until a suitable opportunity for passing the truck exists. Now, the distance, since the unit for that 3 kilometer here is in 3 kilometers, so that is the distance, right? So distance there is 3 kilometer. Now, since distance measured in meter, you need to convert that 3 kilometer into meter. You multiply by 1000. So we'll be having 3 times 1000, that will give us 3000 meter. But the time is not given for that 3000 meters that the car has traveled at a speed of what? 15 meters per second. So what you have to do, you have to calculate for the time. So we know very well that velocity is the change of distance traveled in a specified direction to time, to respect to what? To time, right? Or we can say displacement of the body with respect to what? To time, right? So we say v is equals to s divided by what? By t, where x is the distance, t is the time, and v is what? Is the speed. Now if I make this the time the source of the formula, because that's what we're looking for, we'll say that t is equals to what? S over v. And what is the x here, which is the distance, and that's given as what? 3000 all over the speed v, which is what? 15. And we divide it, you'll be having 200 seconds. So it means that 3000 kilometers that it traveled it for what? For 200 seconds. So you add the 200 plus the initial 10, and that'll give us 210. So at this point here, we're having 210, right? So look at what is happening. It accelerates, reaching a speed of 50 meters per second for 10 seconds, and it maintained this 50 meters per second, right, for the next 3000 meters with a time of what? 200 seconds. Is that okay now? So let's continue. Now, the car then accelerates uniformly to 90 kilometers per hour in further 10 seconds. So it accelerates again from that point. We'll call that point V2, right? And that V2 is given to be 90 kilometers per hour. You convert it to meter per second. That will be 90 times 1000 over 3600, and that will give us 25 meters per second. So in further 10 seconds. So V2 25 meters per second in further what? In further what? 10 seconds. So you add 210 plus 10, and that gives us what? 220. Is that okay now? So this point here is 220. Now we'll continue. In further 10 seconds, right? After maintaining this speed for 5 minutes, so it now maintained the speed for what? For 5 minutes. Is that okay now? After the 10 seconds, it now maintained this speed for what? For 5 minutes. Now we know time is in seconds, so you have to convert this time into seconds. So it will be 5 times 1 minute is 60 seconds times 60, and that gives us 300 seconds, right? So when you use the word maintain, right? When you use the word maintain means you use a straight line to represent maintain. So it means the velocity is constant. The velocity is what? Uniform at that point. So you now add the 300 seconds plus the 220, right? And that gives us 520 seconds. So it maintained 25 meters per second, right, for 300 seconds. It maintained 25 what? 25 meters per second for what? 300 seconds. That what we have there. So this is what we have. Now we'll continue. We're not told that the car is brought to rest by uniform deceleration of 2.5 meters per second square. So we know that when you say this deceleration, means acceleration is what? Negative. So I'll say my A is equals to minus 2.5 meters per second square. The negative there is denoting that what? It is decelerating, or you can say it is retarding, right? And since it is when it's coming from rest, the initial velocity u is 0, right? When it's going back to rest, the final velocity is what? V, which equals to what? 0. So take note. When a body is going to rest, is coming to rest, V, which is the final velocity, is 0. When a body is coming from rest, U, the initial velocity is what? Is 0. So we say my V here is 0. My U is what? Which is the initial velocity, will now be what? What do you think the initial velocity will be? That will be the velocity it was at the last moment before it comes to rest, and that is V2. And V2 is given as what? 25 meters per second, right? So this is what we have here. So when it's coming to rest, 25 what? Meter per second. So what you now do now, we are looking for the time. We are only told here that it is coming to rest, right, with a deceleration of minus 2.5 meter per second square, but we are not given the time. So we need to calculate for the time. So the acceleration is equals to what? Rate of change in velocity right? That is velocity, change in velocity over time. So we say that, and change velocity over time is the final velocity minus the initial velocity all over t, which is what you can see on the screen here. So what is acceleration here? Minus 2.5 equals to, what is the velocity? The final velocity, it is what? 0, like I told you here, this point here, 0, minus the initial velocity is what? 25, right? All over t. So if I make t the set of the formula, my t will be equals to what? Minus 25 all over minus 2.5. So the negative will equal the negative. So 25 over 2.5 will give us what? 10. So the t is equals to what? 10 seconds. So you now add it to 520 and we have 530 seconds. Right? So this is what we have. This is what our velocity will, what our velocity time graph will look like. So let us move forward. So we're now told to calculate for what? The total speed traveled. Now look at this. Let's use V subscript T to be the total speed. Or better still, I can just use what? The total speed. And that will be what? The V1 plus what? V2. Right? And that will be 25 plus 15. And that is what? 40 meter per second. So the total velocity traveled is this. If I said the maximum velocity, the maximum speed, it is 25. The minimum speed is 15. So the total speed is what? The maximum speed plus what? The minimum speed. And that will give us what? 40 meter per second. Right? And we're now asked the total time. So the total time is what? 530 seconds is what we have here. Is that okay? Now we move forward. We're now told to look for what? The average velocity or the average speed. So I will know the average speed is what? The total distance over what? The total time. The total distance traveled over the total time taken, right? So for that, we don't know the total distance traveled, so we have to calculate for that. We know the total time, which is 530, but we don't know the total distance traveled. So for the total distance traveled, we use my S of t. That will give us, let's say this is stage 1 of the motion, stage 2, stage 3, stage 4, and stage 5. So the total distance traveled will be, we use S for distance, that will give us S1 plus S2 plus S3 plus S4 plus S5. So it means the distance, the addition of distance at different stage of motion, right? So when you do that now we'll apply this. So when you're told to calculate for distance in velocity time graph, it will be the area of the shape that the distance form, that the object form when traveling, right? Now in stage 1, now what do you notice? It is a triangle, right? I will know at S1 is triangle, so we know the area of the triangle is half base times what? Times height, or base times height all over 2. So the base here is the horizontal one, which is the base of the triangle, and that is representing the time, and the height is what? The velocity. So since it's stage 1, I will say that the T1, here we'll say here is T1, here is T2, here is T3, T4, T5, right? So we'll now say that T1 times V1 all over 2, just like what you can see here, right? Now, plus the next one, we have a rectangle, right? Which is what? The length times the breadth. And we know the length here is T2 and the breadth here is V1, right? So we'll say that T2 times what? Times V1 plus the area of what? A trapezium, which will be what? The minimum velocity plus the maximum velocity all over 2 multiplied by what? The time T3. Is that okay now? So that is what we have here. And for the third stage, we call it S4, it will be still rectangle, right? Length times breadth. And what's the length? Is a T4 times the breadth, which is the V2, the height here. And that's what we have there. Plus the area of the triangle at stage 5, and that will give us what? Base times height all over what? 2. So it will be T5 times V2 all over 2, right? So when we start inputting our figures. When we start inputting our figures here, let's put in, we know that the T1 here is given to be 10 times the V1 here is given to be what? 15 divided by 2 plus the T2 here is given to be 200. You're wondering, how did I get this value? Now, I want you to understand this. T1 is the difference between the 0 and the 10, that is 10. T2 means 210 minus 10, right? That is the initial time minus the final time at that stage. So T3 is what? 220 minus 210, the initial minus the final of stage 3, the initial time minus the final time of stage 3. T4 is what? The initial time, the final time 520 minus the initial time 220, that will give us T4. T5 is what? The final time minus the initial time at stage 5, which is 530 minus what? 220, right? So we'll now put that, and this is what we're having. So if you look at this, my T1 here is 10 minus 0, right? And that will be 10 multiplied by V1, which is 15, all over what? 2, right? Just like what you have here, plus the T2, which means 210 minus 10, that will give us 200, multiplied by the V1 here, which is what? 15, plus V1 plus V2, which is what? 15 plus 25, right? That's the minimum velocity plus the maximum velocity, all over 2, multiplied by the T3. T3 means the difference of 220 and 210. That will give us what? That will give us 10, right? So we're having 10 here, plus 300 times 25. Now that is T4, difference between 520 and 220, give us 300 times what? V2, and V2 is 25. And we have plus, we have the 10, difference between 530 and 520 is what? Is 10, right? That is T5, multiplied by V2, which is what? 25 divided by 2. Now when you put the needful, 10 times 15 times 2 is 75, plus 200 times 15 is 3000, plus 25 plus 15 divided by 2 all multiplied by 10 will give us 200, plus 300 times 25 will give us 7500, plus 10 times 25 divided by 2 give us 125. Now when you add everything, the total distance traveled will give us what? 10,900 meters, right? So we'll now input this into our equation above. So we'll say that my array velocity will now be the total distance over the time taken, and that is 10,900 all over 530. And the array velocity will be what? 20.56 meter per second. So this is what we have here, right? So this is how you can calculate for each of these questions here, this problem involving velocity time graph, right? So you stay tuned for our next video, where we'll solve other problems related to what? Velocity time graph. So if you have actually found this video helpful, don't forget to like, subscribe, share, and also don't forget to comment if you have any questions that you want to ask. Thanks for watching.